Risk is not just a technical problem, it is a governance problem. In this topic, we'll connect policies, ownership, vendor oversight, and board accountability to the NIST CSF Govern function, so compliance expectations become practical operating decisions. We've built the foundation: AI mapping, healthcare privacy, and GDPR compliance. Now we move from knowing the rules to running the governance system, assigning risk owners, approving decisions, documenting oversight, and using NIST CSF Govern as the guide. NIST CSF 2.0 treats Govern as the decision layer above the operational lifecycle. For AI, that matters because risk includes more than technology. It includes regulation, privacy, vendor dependencies, model behavior, and the authority to accept risk. Govern clarifies accountability before incidents happen. It sets policies, oversight, and escalation paths, then connects AI systems to enterprise risk and business goals. When that foundation is explicit, the other CSF functions work more effectively. An AI governance operating model turns principles into day-to-day decisions. Executives set risk appetite and accountability. Risk, legal, privacy, security, and compliance teams translate that direction into policies and controls. Product and engineering teams apply those controls as use cases move from proposal through review and approval into monitoring and eventually retirement. The key idea is repeatability. Decisions are documented, escalated when needed, and supported by evidence showing why the AI system was allowed to operate. An AI governance board is where accountability becomes practical. It brings security, privacy, legal, compliance, risk, product, engineering, data science, and business leaders into one decision forum. Its charter is the source of truth: who can approve AI use, review risk, oversee vendors, grant exceptions, and confirm deployment readiness. The charter should also define cadence, authority, quorum, voting rules, documentation, and escalation paths, so decisions are consistent and defensible. Decision rights make authority clear. For each risk tier, define who can approve, who must be consulted, and who can block release. Review criteria should cover data sensitivity, purpose, automation level, user impact, security exposure, regulatory duties, and third-party reliance. Higher-risk cases such as PHI, sensitive data, automated decisions, or external models need enhanced review. Keep technical readiness separate from legal, privacy, and enterprise risk acceptance, so each decision is accountable and defensible. Risk ownership has to be explicit, because one system can involve business decisions, model controls, data protection, vendors, and incident response. A useful pattern is to separate who does the work from who is accountable for the outcome. The business owner usually carries residual risk. Technical owners manage model and platform controls. RISI keeps this clear by linking each risk register item, obligation, mitigation, and evidence requirement to named people, not vague teams. Risk appetite sets the boundary for what the organization is willing to tolerate across privacy, safety, fairness, cybersecurity, resilience, and regulation. Once a risk is identified and assessed, teams should mitigate it first. Any residual risk must be formally accepted with an owner, rationale, expiration date, and review cycle. If the risk exceeds appetite, involves material harm, creates non-compliance, affects high-impact decisions, or leaves security gaps unresolved, it escalates to the right governance level. Governance decisions should leave a clear trail, not just a final yes or no. Record the rationale, materials reviewed, participants, approvals, conditions, and any dissenting concerns. Then link that record to the system inventory, DPIA, risk register, vendor review, and control evidence. This matters most for deployment approvals, exceptions, risk acceptances, and retirements. Standard templates keep reviews consistent and give regulators, auditors, customers, and oversight teams evidence they can trust. Policies and standards are where AI governance becomes operational. Policies state mandatory expectations, such as acceptable use, data handling, human review, and when AI may be deployed. Standards go deeper by defining testable requirements, owners, evidence, and control thresholds. Integration is essential. Rules should connect to privacy, security, vendor risk, software development, logging, and incident response. When exceptions are needed, they should be justified, approved, compensated for, and time limited. Acceptable use policies turn AI from an open-ended experiment into a governed business tool. They draw clear boundaries: which tools are approved, which uses require review, and which are off limits. Sensitive inputs need special protection, especially PHI, personal data, credentials, source code, and regulated records. Prompt controls add another layer through redaction, logging, retention, and monitoring. Training matters too, because users must understand hallucinations, confidentiality risks, and when human judgment is required. Governance does not end when a model is approved. Before deployment, teams confirm validation, security, privacy, monitoring, rollback, and user impact controls. During operation, policies define when a human must review outputs or decisions, especially in high-impact settings. Logging captures prompts, outputs, access, model changes, and exceptions. If something goes wrong, AI-specific triggers should feed directly into existing security, privacy, breach, and rollback procedures. AI vendor governance starts by knowing exactly what the third party provides: a model, platform, cloud service, data processing, API, or analytics capability. From there, tier the relationship by sensitivity, business criticality, and decision impact. Higher risk requires deeper diligence on security, privacy, transparency, data use, and compliance. Contracts should lock in those expectations. After launch, continue monitoring performance, incidents, and changes, and link each vendor record to the AI inventory and risk register. Vendor oversight should be proportionate to risk. Vendors with deeper data access, greater AI impact, tighter integration, or stronger operational dependency need stronger controls. That may include BAAs or DPAs, retention limits, sub-processor controls, audit rights, and breach timelines. Validate claims with evidence such as SOC2 reports, ISO certifications, penetration test summaries, and DPIA support. Keep monitoring after onboarding, because incidents, model changes, compliance updates, and sub-processors can all change the risk profile. Governance is what turns AI compliance into daily practice. Clear decision rights, risk ownership, approvals, and escalation make actions accountable. Policies guide acceptable use, data handling, deployment, review, logging, vendors, and incidents. With that foundation in place, we can now identify AI assets, classify data, and model threats.